In this video, I'm going to show you an end-to-end workflow that connects live Databricks data directly in Excel using the new Databricks Excel connector, and then takes that data to the next level with Claude for Excel. The goal is simple: move from governed real-time Databricks data into a familiar Excel interface, and then into rich analytics and executive-ready reporting powered by Claude, all in a single, repeatable workflow. Let's start with the Databricks Excel add-in itself and why it matters. The Databricks Excel connector lets Excel talk directly to your Databricks environment. So instead of exporting CSVs or manually copying query results, you get a live, refreshable connection straight into your Unity catalog tables and SQL queries. This add-in can be deployed centrally by admins at a global level, or enabled self-service by individual users for both Excel Web and Excel Desktop. In this demo, I'm going to focus on the self-service setup for Excel Desktop, which is perfect for power users and data professionals who want to prove value quickly before scaling out. To begin, we'll download the Databricks Excel add-in file from the Databricks documentation and save it locally. Once that file is downloaded, I'll open it up in VS Code so we can configure it. Inside the file, there's a section where I can specify the Databricks workspaces this add-in should connect to. I'll add my workspace URL into that section. And note, you can add multiple workspaces here if you work across different environments. Later on, inside Excel, you'll be able to toggle between those workspaces from the Databricks connector pane. For this demo, I'll just add one workspace URL, save the file, and close VS Code. Next, I need to make Excel trust this add-in. To do that, I'll create a folder on my C drive called something like Manifest, and I'll copy the Databricks Excel add-in file into this folder. Then I'll share this folder so it's available as a trusted catalog. I'll right-click the folder, go to Give Access to or Properties depending on your Windows version, click Sharing, and then click Share. I'll add myself as a user with read and write permissions and complete the sharing process so that this folder can be referenced by Excel as an add-in catalog. Now, I'll open Excel Desktop. Inside Excel, I'll go to File, Options, Trust Center, then click Trust Center Settings. In the left sidebar, I'll choose Trust Add-in Catalogs. In the Catalog URL field, I'll enter the UNC path to the shared manifest folder I just created, for example, your computer name /manifest. Then I'll click Add Catalog, check the Show in Menu checkbox so that this catalog appears as a source for add-ins, and click OK to save these changes. I'll close out of the settings and restart Excel Desktop so the new catalog is recognized properly. After Excel restarts, I'll go to the Add-ins tab, click Advanced, and from there, I should see the Databricks connector listed as an available add-in under the shared catalog. I'll select the Azure Databricks connector from that shared folder and add it to Excel. Once added, the connector will appear in the Excel ribbon, and I can then click to open it. The first time I open it, I'll sign in using my normal Databricks authentication flow, whether it's SSO, MFA, whatever my organization has configured, so everything stays consistent with existing security policies. With the connector open and authenticated, I can now see my Unity catalog structure within Excel: catalog, schema, tables, and views. From here, I can import data into my workbook in two main ways: directly from the tables and views or by using custom SQL queries. Each dataset I import becomes a live connection back to Databricks, which means I can refresh it without rebuilding everything from scratch. For this demo, I'll bring in one dataset using the table import method and another using a SQL query. Let's start by importing from a Unity catalog table. In the Databricks pane, I'll navigate to my catalog, select the schema, and choose a table that contains my gold dataset into a new tab. Almost instantly, the data appears in the sheet, and that connection remains live back to my Databricks Unity catalog. This is Sheet 1, and it now represents a governed, refreshable view of my gold level customer analytics. Next, I'll demonstrate the SQL query option. In the connector, I'll switch to the import type from tables and views to SQL queries. I'll paste in a more complex SQL statement that does several things in one shot. At a high level, this query starts by building a retention CTE that calculates retention rates, average monetary values, and counts of champion customers by segment and country. Then joins back to suppliers for a full 360 customer view. I'll go ahead and import this into Sheet 2. At this point, I now have two live datasets in my Excel workbook. Sheet 1 with the core customer RFM table imported directly from Unity Catalog, and Sheet 2 with a curated analytics-ready dataset built for a more advanced SQL query. Both are backed by Databricks, both are refreshable, and both reflect governed data from the Lakehouse. This alone is a big win. Business users get live data in Excel without manual exports, and data teams keep everything anchored in Unity Catalog. Now, it's time to bring in Claude for Excel into the picture. In the same workbook, I'll switch over to the Claude add-in for Excel. With Claude available, I can ask it to look at both Sheet 1 and Sheet 2 and help me design a meaningful analytics experience. Instead of manually creating pivot tables, charts, and dashboards, I'll describe what I want in natural language and let Claude do the heavy lifting. Start by asking Claude to examine Sheet 1 and 2 and propose a comprehensive analytics dashboard for executive reporting. Claude responds with a clear plan. Claude then builds two sheets for me, an analytics sheet with all the pivot-style summary tables and charts, and a dashboard sheet with the executive KPIs and highlights. On analytics, it summarizes revenue by product, region, and country, plus segments and customer distributions, and wires each table to the right bar and pie charts. On the dashboard, it turns those results into KPI cards, segment and regional views, and top products, automatically fixing formula issues, formatting numbers, and aligning visuals. By the end, I have a polished executive-ready analytics sheet and dashboard that clearly show performance by region, country, and segment, plus how many customers are at risk or lost. Now, what started as raw Databricks datasets has now turned into a fully interactive, executive-ready analytics experience. Without manually writing formulas, dragging pivot table fields, or configuring chart options, Databricks provides the secure, governed data layer and the heavy lifting on transformation. The Excel connector delivers that data live into a tool business users know, and Claude for Excel sits on top as an intelligent analytics partner that designs, builds, and refines dashboards on demand. To wrap it up, the combination of the Databricks Excel connector and Claude for Excel fundamentally changes how teams can work with analytics. Instead of exporting static snapshots, you maintain live connections to your Databricks Lakehouse. Instead of manually constructing every pivot and chart, you describe your goals and let Claude build and iterate. This workflow saves hours of tedious work, reduces errors, and keeps your reporting aligned with a single source of truth. Most importantly, it puts powerful, governed analytics in the hands of executives and analysts in the interface they already live in, Excel, while still leveraging the full power of Databricks and modern AI. Thanks for watching.